Hello, and today we're going to be talking about prime, composite, and factorization. We're also going to be talking about the greatest common divisor and least common multiple. Okay, so we got a lot to talk about with this session. First of all, what do I talk about when I mean prime and composite? Well, composite are the numbers you are most familiar with, because composite numbers are what I call the pretty numbers. Okay? The pretty numbers are the numbers that are easy to deal with. Okay? Pretty numbers. They're easy to deal with, and they're basically easy to divide by, multiply by. What are the composite numbers? They are the composite numbers are numbers that are divisible by prime or composite numbers. Okay? So example, 24. 24 is a composite number because it is divisible 2 times 12, those are two composite numbers. Or you could divide it 3 times 8, which is a composite and a prime, or 3 times 2 times 2 times 2, which are all primes. So 24 is a composite number because it's divisible by anything, pretty much, composite or prime. Give you a list of composite numbers. Well, it's easier to give you the list of prime numbers because that is what we're going to focus on. Prime numbers are the numbers, a lot of people say odd, but they're not. Okay, prime numbers, there's that eraser again. Prime numbers are numbers that are only divisible by themselves and 1. Numbers that are divisible by themselves and 1. I'm going to make this 1 look fancy so you know it's not a I or an L. Okay? Numbers that are divisible by themselves and 1. Give you an example. 1, 2, 3, 5, 7, 11, 13, and so on. Okay? Now, those of you that say they're all odds, no, because 2 is in there. Well, most of them are odd. Well, where's 9? 9 is in composite because 9 is divisible by 3 and 9. Divisible by themselves and 1. Those are the ones that are hard to deal with. Okay? For instance, 27 is not a prime number, but 29 is. How do you know? Well, 29, you got to, again, it goes back to the multiplication tables that you're supposed to have learned. And give me a multiplication table of 29. Well, it's only 1 times 29. Bingo, you got a prime number. Now, you can go to Google and you can look up prime number sheet and print out a prime number sheet and try to memorize as many as you can. But most of the time, you can figure it out by the number it ends with. Okay? So, with that being the case, the prime factorization is what we're going to focus on. Well, you used another big word, factorization. Yes, factorization. Factorization is a 25-cent word for breaking it up into its factors. All right? I'm not going to focus too much on the composite numbers because most of you can do that because of your multiplication tables. That's just factorization. Factorization. Okay? Why is it not prime factorization? Prime factorization is when you break it up in terms of its what? Prime numbers. That's the difference between factorization and prime factorization. I need you to write that down so you will know, because everything we do from here on out on this video is going to be in terms of prime factorization. I want you to kind of forget your composite numbers for the next few exercises or the next few screens, because we will be doing everything in terms of prime numbers. And I'm going to focus on these 5 or 7 right here. 2, 3, 5, 7, 11, and sometimes 13. A, E, I, O, U, and sometimes Y. 2, 3, 5, 7, 13, and 11, and sometimes 13. I'm going to use those predominantly while I am breaking up the prime factors. Now, the prime factorization will also fall into your greatest common divisor and the least common multiple, and the least common multiple transitions into your common denominator later in fractions. Okay, so we're going to touch on that before we go into the fraction review, because it's very important. So while I'm giving you the definition of composite and prime, we're going to focus on this video, in this review video, we're going to focus on the prime numbers and the prime factorization. Now, I do it a little bit different than a lot of people have learned it. So I want you to kind of keep an open mind and say, okay, I'm going to try to learn it the way he's doing it, because it might be a little bit easier. Okay? So the next slide, we're going to focus on prime factorization. And I'm going to get rid of this. I don't know why that's there. Prime factorization. Now, your prime factorization is basically breaking up all numbers into the factors of the prime, or the prime factors, whatever you want to say. Let me erase that line, it's crooked. And most of the time, I'm going to use 2, 3, 5, 7, 11, and sometimes 13. I have found that most numbers can be broken up by those 6 prime numbers. So, what do? Well, first, you're given a number. Well, I'm going to use 54. I always use 54 when I'm first starting out, because the first, if I say factor 54, 99% of the class will say, oh, that's 6 times 9, because you know your multiplication tables. Well, that is correct. That's a good factorization of 54. But somebody might say, oh, that's 2 times 27. That's another factorization. But I don't want the factorization. I want the prime factorization. So what I tell students to do is I use a chart like that, and I put my numbers on top, 2, 3, 5, 7, 11, and sometimes 13. Those are the only numbers I can use. Now, it's very important that you understand that, because somebody's going to say, well, 6 will go into 54. You're missing the whole point. 6 is not a what? 6 is not a prime number. Okay, so I don't like the way that looks, so I'm going to bring that down. Probably not going to let me. Yeah, if I didn't think it was. Okay, so I'm going to divide. Again, remember me telling you in the previous videos, remember me telling you that the multiplication, your math tables, this is where your math tables come into play. If you're counting on your fingers, or if you're doing it by hand over on the left-hand side of the paper, that's not acceptable. You should be doing it like I'm doing it, okay? So, I don't care. You can pick any number you want if it's divisible. I always pick 2 or 3, unless it ends in a 5, okay? Now, right quick, I'm going to go over, and I'm just going to pull up a divisibility table for you. I do this in class a lot, so I'm going to pull up over here. I'm going to pull up divisibility table. And you might want to pull it up also, divisibility table, and hit images. And there's your divisibility tables. I'm going to go ahead and copy one so you can look at it. I'm just going to copy this one right here. Copy image. And I'm going to bring my handy dandy whiteboard back up. And I'm going to pull this in so you can look at it. Well, no, I'm not. Hold on. I'm going to hit clipboard. There we go. Now, those of you that have had basic math before, whether it's been 1,000 years ago or whether it's been last year or whatever, some of you may remember this division. Go ahead and look at it. Most of the time, I'm going to use 2 or 3 to begin with. But what if it ends in 5 or 0? Then I know it's divisible by 5. Okay? This is something you might want to write down or make another note. It kind of helps you with this section. Okay? Now the tables, you still need to know the tables because you need to know your multiplication tables, division tables, and things like that. This helps you kind of narrow it down to what you need to divide by. I use 2, 3, and 5 most of the time. So I'm going to use 2. 2 will go into 54 27 times. 2 will go into 54 27 times. Now I can't use 2 anymore because I know 27 is only divisible by 3 and 9. How do I know? Well, my multiplication tables and that divisibility rule sheet right there says that if you add the 2 up, 7 and 2 is 9. If you add it up, then you can divide it by 3. So I'm going to divide by 3. That'll give me a 9. Divide by 3. That'll give me a 3. Divide by 3. 1. 1 is what you want. Let me make that a green 1. Sorry. A green 1. Because that is what you want. When you get a 1 down there, that means you have just factored your number by prime numbers. And your prime factorization is 2 times 3 times 3 times 3, or 2 times 3 to the 3rd power. And that is your answer. Now again, the first person the student will raise their hand after I show them this problem, and they'll say, well, wait a minute, can't I write that as 2 times 27? Again, you're missing the boat. We are not writing in terms of what? Composite numbers. We're writing in terms of prime numbers. So again, you need to kind of remember that we are using prime numbers. We're not using the composite numbers. 2, 3 to the 3rd power. So let's do some prime factorization. So let's do 144. Find the prime factors of 144. I draw my line. 2, 3, 5, 7, 11, and sometimes 13. Now I'm going to give you a minute. I want you to pause the video, and I want you to go through and do that problem as much as you can, and if you can't, we'll do it together. Okay, now that you're back, I'm going to divide by 2. Why? Because it ends in 4, and from that previous table that you go to Google and print out, if it ends in an even number, then you can divide by 2. And I always use 2, 3, and 5 first. So I'm going to go up here, and I'm going to highlight 2, 3, and 5, because I always use those first, just as a general rule. So I'm going to use 2. 2 will go into 14 7 times. 2 will go into 4. Now, did you notice what I did? I did that long division in my head. How? Because I know my tables. If you're doing this over here, 2 into 144, if you're counting on your fingers, no fingers. No fingers, no long division. You got to do it in your head. Now, I'm telling you that for you to be successful. I'm not telling you that to hurt your feelings. I'm just telling you that I'm pragmatic. I'm very real. I tell you the way it is. 72 is even, so I'm going to divide again. 2 will go into 72 36 times. 2 will go into 36 18 times. 2 will go into 18 9 times. I can't divide by 2 anymore, so I'm going to divide by 3. 3 will go into 9 3 times. 3 will go into 3. Ding, ding, ding. 1. We got our 1, so that means we're done. Now, a lot of people say, well, Hubert, I divided by 3 first. It doesn't matter. Remember, let's go by the commutative law again. Let's go by 2 times 3 is the same as what? 3 times 2. 2 plus 3 is the same as what? 3 plus 2. So does it matter whether you divide by 3 first or 2 first? No, it doesn't matter, because this over here, the 2 to the 4th power times 3 to the 2nd power, you're going to get that no matter if you start with the 3 or if you start with the 2. You're going to get the same answer I got. So hopefully you got that one right. Let's do another one. Let's do 235. 2, 3, 5, 7, 11, and sometimes 13. And of course, I'm going to let you pause the video, but why did I underline the 5? Because it ends in 5. That's the only number you can use. You might could use 7. I don't think you can, because 7 will go into 35, but I don't think it'll work here. 5 I know will work because it ends in 5. So go ahead and pause the video and get your prime factorization for 235. Okay, you're back. Let's divide by 5. And when I'm dividing by 5, 5 will go into 23 4 times. That'll leave 35, be 7. Ooh, I don't know if we got anything to go into 47. 7 won't go into it. 3 won't go into it. 2 won't go into it. 11 times 4 is 44. That won't go into it. 13, 3, no. I'm trying to think. 4 times 13 is 52. So your prime factorization is 5 times 47. All right, let's do another one. Let's go ahead and do a bigger one. Let's do 525. Or let's see, 625. 2, 3, 5, 7, 11, and sometimes 13. So I'm going to start with 5, but I'm going to let you pause the video and take as much time as you need, using those 6 numbers at the top to divide that out and get your prime factorization. Okay, we're back, and divide by 5. 5 will go into 6 1 time. That'll leave 12 2 times. That'll leave 5, 25. Divide by 5. 5 will go into 12 2 times. That'll leave 25. And 5 will go into 25 5 times, right? And 5 will go into 5 1 time. There's our, I'm trying to get my green, there we go. So 5 to the 4th power. So that's your prime factorization of, so let's multiply. 5 times 5 is 25. 5 quarters is 125. What is 5? You got 5 people with $1.25 in their hand. Well, you can do the math. It's $6.25. So that's your answer, 5 to the 4th power. 1,024. 2, 3, 5, 7, 11, and sometimes 13. I know I'm going to divide by 2. Why not? Why am I going to divide by 2? Because it ends in 4. It ends at even number. You've got to have 3 or 4 things to do prime factorization. 1, you've got to have your tables. You need to know your tables by hand. That's your your multiplication table, your division table, your addition table, and your subtraction table. You've got to know your numbers. 2, you've got to know the divisibility table. That table I just showed you a while ago. If it's even, you divide by 2. If it ends in a 5 or a 0, you divide by 5. If it ends in a number, if you add the numbers up and it's equal to 9, you can divide by 3. Those are very important in this section. So I'm going to divide by 2. 2 will go into 10. 10 5 times. 2 will go into 2 1 time. 2 will go in there 2 times. Ends in 2, so I'm going to divide by 2. 2 will go into 5 2 times. That'll leave 11. 5 times. That'll leave 12. I'm going to divide by 2 again. Now, if you're going over to the side and you're doing 1,024 divided by 2, or you're using a calculator, you're missing the boat. We're going to go back and tell you one more time. You would be surprised on how many people can't do math. And the only reason they can't do math is because they never learned these 2 tables or 5 tables. They never learned them. They either relied on counting on their fingers, or they relied on long division and they never learned the quick ones, or they used the calculator too much. So 2 will go into 2 1 time. 2 will go into 5 2 times. That'll leave 16. That'll leave 8. I can still divide by 2. 2 will go into 12 6 times. 2 will go into 8 4 times. 2 will go into 64 32 times. 2 will go into 32 16 times. 2 will go into 16 8 times. 2 will go into 8 4 times. 2 will go into 4 2 times. And 2 will go into 2 another, and you get 1. So 1 2 3 4 5 6 7 8 9 10. 2 to the 10th power. And that's how you do the least common multiple. That's how you find the prime factorization. Now, next I'm going to show you, on this video, I'm going to show you how to do the least, what we call the greatest common divisor and the least common multiple. Greatest common divisor and the least common multiple. What are they? Well, the greatest common divisor, and you can write that down, stop the video and write greatest common divisor. I'm not going to write all that out. The greatest common divisor is the biggest number, or the largest number, whichever one you want to use. The biggest number that divides into the numbers given. You'll see that in just a minute. The biggest number that divides into the numbers given. Where the least common multiple is the smallest number that the given numbers will divide in 2. So your greatest common divisor is usually going to be the smallest number, and then the least common multiple is going to be your bigger number. So this is going to be a relatively small number. I can't write. Oh, me. There we go. Smaller number, and then the least common multiple is going to be a big number. Now, again, I'm going to warn you that I teach this differently, or I teach it different from other books or other teachers. So you may run into a problem here, but it's a whole lot easier the way I do it. I've tried to teach the other way, and it just doesn't work very well. So we're going to do it the way I do it. All right, so go ahead and pause the video and write that down. And remember, the first one's called greatest common divisor. The second one is called the least common multiple, and this one turns into our common denominator, least common denominator, or greatest common denominator, I can't remember, least common denominator later. In other words, it's the smallest number that both denominators will go into. So we're going to use the least common multiple in our fraction videos when we do the fraction videos next. All right, so let's go ahead and start with a simple problem. Let's go with find the greatest common divisor and the least common multiple of the following numbers. Let's go with 14 and 20. Okay, find those. Find I'll put the directions at the top. Find the greatest common divisor and least common multiple of the following. All right, the first thing I'm going to do is I'm going to rewrite those two in my chart. I'm going to do 14 and 20. I'm going to put them in order. And I'm going to do 2, 3, 5, 7, 11, and sometimes 13. That's what we just got finished doing. But now we've got two numbers. And you can do this with 2, 3, 4, 5 numbers. And later on, you're going to see it become very nice when you have common denominators. When you don't have common denominators and you have to find a common denominator. So they both are even. So I'm going to start with 2. And 2 will go into 14 7 times. 2 will go into 20 10 times. And I'm going to put a red line under this. Why? Because the real math stops. Why does the real math stop? The real math stops because there is no other number that will go into 7 and 10. Well, Hubert, 7 will go into 7, yes, but 7 won't go into 10. 10 will go into 10, but 10 won't go into 7. So you have found, when you have done the real math stops, that number right there is your greatest common divisor. So what does that mean, Hubert? That means that 2 is the biggest number that will go into both 14 and 20. 2 is the biggest number that will go into 14 and 20. So we're going to go over here and we're going to write that down. Our greatest common divisor is equal to 2. That means that 2 is the biggest number that will divide, I'm just going to put a division symbol, that will divide into 14, and 20. So it's very important that you write that down so you understand what the difference is between the greatest common divisor and the least common multiple. Now we're going to use what I call magic math. In other words, we want, I'm going to do this in blue, I'm going to use magic math to try to get ones on the bottom by using these numbers right here. Now, in magic math, you cannot divide. If it causes a decimal or a fraction, you just bring it down. If a number cannot go into another number, you just bring it down. So, what numbers can I use? Well, I can use 2. 2 will go into 10, it won't go into 7, so I'm going to write 2 down. You don't have to use 2. You can use 5. You can use 7. I can use one of those 3 numbers. What if I use 7 first, Hubert? And put a 7 right here, and 7 will go into 7 one time, but 10 will have to come down because you can't divide 7 into 10. So I'm going to use 2. I'm going to do it in blue. 2 will not go into 7, so I bring it down. That's the magic math. If it doesn't go into 7 or whatever, you just bring that number down. Will 2 go into 10? Yes, 5 times. And I want ones. I want my ones down here. I want 2 ones. So that's my goal. So now I'm going to divide by 5. Will 5 go into 7? No. So you bring it down. Will 5 go into 5? Yes, 1 time. Hey, there's one of my ones. So I got one of them. Now what do I need to do? Divide by 7. 7 divided by 7 is 1. Good. And 1 comes down. So I've got my ones. When you get your ones, when you get 2 ones, you have found, and I'll do it in blue, you have found the least common multiple. So our least common multiple is equal to, well, I'm going to multiply this 2 times 5 right here because that's 10, and you can multiply 10 by anything. 7 times 2 is 14, so that's going to be 14 times 10, which is equal to 140. That is my least common multiple. The least common multiple is the smallest number that 14 and 20 will divide into. So how many times will 14 go into 140? 10 times. How many times will 20 go into 140? 7 times. And later on, this is what's going to be called your common denominator when we put it in that application. So it's very important that you learn how to find the least common multiple. Now, I realize that some of you have never seen this before, and some of you have seen it in a different perspective with a tree, but I don't use the tree. I've tried to use that tree several times, and students, they don't understand it. So if it's broke, if it ain't broke, don't fix it. If it is broke, fix it. So I just went with something different. All right, so let's do another one. We're going to do 30 and 50. Two, 3, 5, 7, 11, and sometimes 13. Pause the video and work it out while I try to get rid of this eraser that comes up every now and then. Pause the video and work out this problem. Find the least common multiple and the greatest common divisor. Okay, coming back. I'm going to divide by 5. Why? Because it ends in 0. So I'm going to divide by 5. Do you have to? No. You could divide by 2 if you wanted to, and then it would, it would work its way out. But I'm going to divide by 5 because it ends in, both of them end in 0 or 5. I can divide by 5. 5 will go into 30 6 times. 5 will go into 50 10 times. Can I divide anything into these two? Yes, you can divide by 2. And that'll give you a 3 and a 5. Up, real math stops. Why does the real math stop? The real math stops because nothing will go into 3 and 5. Well, 3 will go into 3, but 3 won't go into 5. Well, 5 will go into 5, but 5 won't go into 3. So the real math stops. So when the real math stops, we've got our greatest common divisor. 2 times 5, which is 10. 10 is the largest number that will divide into 30 and 50. Well, 15 will go into 30, but 15 won't go into 5. Well, 25 will go into 50, but 25 won't go into 30. So you've got to understand what you're looking for. In the red, we got our greatest common divisor. Now I'm going to keep going with magic math. So I'm going to turn it to blue. And what is the goal of magic math? To have ones across the bottom. That's the idea. So take your pick. You want to divide by 3 or 5? I'm going to divide by 3. Since I read from left to right, I'm going to divide by 3. So I'm going to divide by 3, and that gives me a 1. Hey, there's one of our 1s. And 5 comes down because you can't divide 5 by 3. And then 5, and that comes down. And 5 divided by 5 is 1. We've got our 1s, and this is our least common multiple. So our least common multiple is equal to, this is a 10 right here, so I'm going to multiply this first. 10 times 15 is 150. 10 times 15 is equal to 150. So 150 is the smallest number. Smallest number that 30 and 50 will divide into. Now, I can tell you from a basic math standpoint that if you don't learn how to find that least common multiple, you're going to have a hard time with finding complicated fractions, adding and subtracting complicated fractions, because you can't find the least common multiple. And I'll give you an example of that in just a minute. We're going to do one more, so therefore you can get this down. We did 2 or 3 with just finding prime factorization. Now we're going to do 2 or 3. I think this is the third one we're going to do with greatest common divisor, least common multiple. I'm going to give you 3 this time. So let's go with, let me get rid of that eraser. Okay, let's go with 25, 50, and 75. Give you 3 numbers, 2, 3, 5, 7, 11, and sometimes 13. And after this, I'm going to do a couple of fractions where you can see, I'm not going to teach you fractions with a couple of, I'm going to show you how this is used in adding and subtracting fractions. So take a minute, pause the video, and do the problem. And hopefully you're pausing it, because I only count 5 seconds. So pause the video. And now you're back. And I'm going to divide by 5. Why am I dividing by 5? Well, all of you should be saying, because they end in 5 and 0, Hubert. That's right, class. So 5 will go into 25 5 times. 5 will go into 50 10 times. 5 will go into, let's see, 15 times. Yep. Hey, I can divide by 5 again. That's right. So divide by 5 again. 1. Hey, we got a 1. That's good. That's good. 2 and 3. Then real math stops. Why does the real math stop? The real math stops because 1, 2, and 3 are prime numbers. So anytime you get prime numbers on the bottom, the real math stops because the only thing that goes into it is itself and 1. So the biggest number that will go into 25, 50, and 75, greatest common divisor, is equal to 25. Now I'm going to take my blue marker, and we're going to get our 1s on the bottom. We already got 1. I'm going to go ahead and mark that 1 right there because we already done that one. So I got to divide by 2. This will come down. 2 divided by 2 is 1. 3 will have to come down. 3, that one's will come down. That one comes down. And 3 divided, we got our 1s. So once we got our 1s, we've got our least common multiple. Least common multiple, let's see, this is 10, so I'm going to use that to make it easy. 5 times 3 is 15. So our least common multiple is 15 times 10, which is 150. So 150 is the smallest number that will go into, or the smallest number that 25, 50, and 75 will what? Go into. Now, that's how you do the greatest common divisor and the least common multiple. Well, how does it relate to fractions? Well, I'm going to show you a couple of problems. And our next series of videos will be fractions, so you're going to get some more of this. So I'm going to show you. Here is a problem. 1 over, oops, I don't like to write in red. Okay, 1 over 25 plus 3, well, not 3, let's go with 7 over 75. Now this is a complex fraction because most people don't think in terms of 25ths and 75ths. So this is a problem, that you're going to have to find a common denominator. So what you do is you go over here and you say 25 and 75. And you don't care about the greatest common divisor, 2, 3, 5, 7, 11, and sometimes 13. You don't care about the common divisor, the greatest common divisor here. All you want is the least common multiple. So I'm going to do it in blue, so you'll relate that back to what we just did. So I'm going to divide by 5. 5 and 15. I'm going to divide by 5 again. That'll give me a 1 and a 3. And I'm going to divide by 3 again. And the 1 will come down, and that's 1. So we got our 1s. So here is our least common multiple. Our least, excuse me. Our least common multiple is 3 times 25, which is 75. So our common denominator is 75. Now, a lot of people, they don't know how to do this over here on the right. They don't know how to do the least common multiple, and they'll just multiply 25 times 75, and that'll make that their common denominator. Or they'll do something else. I don't know what they'll do, but they usually get it wrong. Now, and we'll go through this in the fractions in the next coming videos. Now I want to convert. 25 will go into 75. Well, here's 25 right here. 25 will go into 75 3 times. 3 times 1 is 3. 75 will go into 75. 1 times 7 is 7. And our answer is 10 over 75. Now, I'm not showing you this problem so you can master fractions. That's in the next set of videos. This problem, I'm showing you how it ties to fractions and how you have to have a good background in finding the least common multiple in order to find the greatest common denominator. Okay? So let's do another one. And let's do one that's not so simple. Let's do one that you have to really think about. 1 over 3 plus 2 over 7 plus 7 over 26. Now, unless you take a calculator and do some manipulation with the denominators here, you're not going to know what the denominator is on this one. So you go over here and you write 3, 7, 26. And I'm going to use, I only care about the least common multiple, so I'm just going to use blue. 5, 7, 11, sometimes 13. I'm going to use blue, so I'm just going to go to get my ones. So I really don't see anything that's divisible into any of them because 7 messes that up and 3 does too. So I'm going to divide by 3, and that'll give me a 1. This comes down. 3 won't go into 26. 13 will, but not, so that's 26. 7, that comes down. 1, 26 comes down. 13, that's a 1, that's a 1, that's a 2, and then 2, 1, 1, and 1. So here is your least common multiple. Now, the good thing about this, and this is the trick, all right, it's very difficult to realize what this is right here because you've got 21 and 13 and 2. So that's 26 times 21. I think it's 26 times 21, pretty much. And that's what you got right here, 26 times 21. So I'm just going to do this. I'm going to rewrite my denominator as 26 times 21. 26 times 21 plus 26 times 21. Now you can put that in a calculator and get some big number, but I'm not going to do that because I don't know how to divide it by using the calculator. So I'm not going to depend on the calculator. I'm just going to say 3 will go into 21. How many times? 7 times. 7 times 26 will be right here. Okay? 7 will go into this. 3 times 26 times 2. And 26 will go in here. 26 times, that leaves 21 times 7. Now, you can do that another way, but again, I'm not teaching you how to do fractions right now. I'm just teaching you how to find a common denominator. And of course, that's going to be 26 times 21 on the bottom, which is going to be a big number. And then up here, you got 7 times 26. Well, what's 7 quarters? $1.75, right? And $1.75 plus 7 is like $1.82. So that's 182. And y'all have to check me on this because I'm not using a calculator. 3 times 26 is 52. 52 times 2 is 104. And 27 times, that's 147. So if you take those numbers, 182, that's going to be 286. 286 plus 147 over 26 times 21. And that's going to give you 433 over 26 times 21. Now, I really don't care if you understand that because I'm just showing you how the common denominator works with the least common multiple. Okay? So that is how you find the greatest common divisor, how you prime factor, how you do the prime factorization of a number, how you find the greatest common divisor of a number, and how you find the least common multiple of a number, and the least common multiple later translates into a common denominator.